Alright, so here we go with law of averages, SAT. Some of you have already seen this because I was going over it with you in class, but hey, just as a little refresher, you've got this. So you've got the mean average, which is equal to the total divided by the number of things, and the total is, of course, equal to the average times the number of things. If I go too fast, there's this thing called the pause button. Make sure you press it, and then just copy whatever you need, okay? That's the beauty of these videos. Okay. That's enough for sarcasm for today, I guess. Anyways, and they give you this diagram. The total, the average, the number of things times divide, whatever. Basically what this is saying, like, look, if you needed the total, you do the average times the number of things, because there are times in between, to get the total. If you need the average, you do the total divided by the number of things. Notice how the total is on top and gets divided. So that's kind of how that's kind of set up to kind of help you remember that. So kind of visualize it, and hopefully you've got it. Anyways, so let's look at an example. You want an 80 test average on 4 tests. You scored 85, 76, 99, 50. What do you need on the 5th test to get an 80 average? Okay, so look. You're not just going to just add these up and divide by 4. That gives you the current average. But what do you do to get the 80 average? Okay, so what do you need to get next? Okay, well, if you would add them up like you normally would. But there's that 5th test that you don't know about. And it's equal, and divide that by 5, you would get an 80. So if you think that you don't have the complete total, you need to find out what your complete total is, but you do have the average and the number of things. Okay, according to this, I've got the average and the number of things. Both of those are complete. Then I can multiply those and get 80 times 5 is 400. Then I can go ahead and add up the rest. That's 310. And just like that, it looks really easy to figure out what do you need to get on that test now. Now you need to get a 90. Yes, you could plug in different numbers and keep trying to do that and divide by 5, see which one gives you an answer in 80, but that could take time. So again, we're talking about efficiency here. Efficiency is of utmost importance. So there you go. I'm not going to worry about the rest of that stuff because otherwise it'll get too confusing, but you can see it. Alright, so next example. You have a quiz, average of an 85, which counts 40% of your final average. What does your test average need to be to have an 80 overall average? This is what is known as a weighted average. A weighted average makes you have to like kind of figure out something slightly different. So you have to do a little bit different there and kind of go from there, saying that 40%, how do I do that, and so on and so forth. So what I do, 40% is 0.4. That means the test averages are 60%. And I want a total of an 80. Okay, well I know I can put a number in place of the x, or in place of the 40% of 85. So I'm looking for the 60%, which is x. Now if you can see here, 4 times 85 is 34 points. So you've earned 34 of the 80 points you want. If you subtract those two, you need a 46. You need 46 points. That doesn't mean you need a 46. You need 46 points. Well, how do you earn that 46? You do 0.6 times whatever the x is to get the 46. Well, that also means you can divide, and you would get that you would need about a 77 if you round it off, because it's 76.6. Okay, so you need about a 77 to get test average to make sure you have an 80 overall average. So those are what are called weighted proportions, or weighted averages, and you should be very careful with those. I'm trying to make sure, and I'm looking here, and we'll talk about some more of those in a second. But now let's look at one last one. And this one I kind of made up on the fly, so again, there could be variations to this problem, so always keep that in mind. There's always, say, a variation, and the question is, can you adapt to that variation? So, on my way to Corpus, my trip computer said I had traveled 150 miles for an average speed of 60 miles per hour. According to Google Maps, I traveled 110 miles at 75 miles per hour. What was the average speed of the rest of the trip? Well, hold a second here. I'm going to stop that right there. Let me double check something here. Okay, so I'm going to stop right there. Okay, so we're talking about averages here, and if you were in my 5th period class, whatever I showed you was messed up. I messed up there, and I'll admit that. So let's think about this. Okay, we talk about an average, and we're also talking about distance equal to rate times time. I do know I went 150 miles at an average speed of 60 miles per hour. So I can figure out that at that speed, it took me about 2.5 hours to make my trip, which is true. I also, according, like I said, Google Maps said I was going to travel 110 miles at 75 miles per hour. So when I was able to keep doing that the whole way, then that part of the trip would have taken about 1.47 hours, almost an hour and a half. Okay, so that means that the rest of the trip, the other 40 miles, let's say, took a little bit over an hour and 3 minutes, or an hour 0.03, not 3 minutes. I should not ever say it like that. 3/100ths of an hour, whatever that might be. Like, let's say another minute. Either way, if I think about that and say, okay, I went 150 miles, I travel 110 at another speed, then that means I went 40 miles at that speed, or 40 miles in the 1.30 hours. So divide those two, and you'll get 38 miles per hour. So it took just over an hour at an average speed of 38.8 miles per hour to go those other 40 miles. As you go through towns, you may have to slow down, stuff like that. So there was that. And I can show you how that relates to the average later, but I just want to make sure I make that correction. The average speed here for this problem, the rest of the trip was 38.8 miles per hour. Okay, so I do apologize for those of y'all in 5th period where I showed this wrong, but there you go. And thank you very much for your time.